Alright, what we're going to be doing in this video is to take the data that we recorded into Excel and find a way of getting that into QGIS. Relatively simple process, although there is one hitch or hiccup, a very slight difficulty, but something that we need to pay attention to regardless. Alright, so what I have here, this is QGIS, and what we're going to do is bring in the layer that we're going to be adding the information to. So we want to click on Add Vector Layer, and I want to browse for the file, and I want to bring in the shapefile. That's all we're really going to be doing, bringing in that shapefile, and open it up. And so here we have the downtown area. This right here is the layer. It is in this layer library. It's turned on. It's ready to go. And just to sort of show you what we're going to be adding to, if I right click on the layer and I open that attribute table, what the attribute table is basically a spreadsheet that describes all of the information as we go from column to column, and as we go from row to row, each row is a single parcel. And so you'll notice at the end of the file here, what we don't have is the sector or block numbers, the dimensions, LBCS dimensions. We don't have the tax value, and we also don't have an indicator of whether there is local ownership or absentee ownership. That's information that is going to be added to this table here. All right, so I'm going to close that. And then what we're going to do is look at the Excel file. So here we have the Excel file in its more or less original glory. It has been trimmed a little bit, but what we're going to do is to create a file that we're going to be joining to the QGIS table, and I would like to have it, I guess we could say, as clean as possible, meaning that I just want to have the information that we collected in our field work, right, this information here, and the information that we generated within Excel from the data that exists in our data set. Everything else is kind of duplicate, but it's unnecessary. Oh, and the only other field that I want is this parcel ID file. This is the key field. It's this data right here, this information that is used to identify which information in this Excel file gets joined to which parcel in the QGIS shapefile. So what I'm going to do is just erase everything else or delete everything else, and that's these columns right here. So I'm going to select those, click delete, and what I'm left is this common field, parcel ID. It's going to help us join this data to the QGIS data, and then everything else that we either collected or generated. All right, so once I have this, I need to save this as a comma delimited file. QGIS doesn't accept as import any sort of Excel file. And there's something slightly problematic. This is where we sort of get the hitch. We're actually going to have to create an additional file along with this. And the reason why we need to do this is that by default QGIS reads in comma delimited files with all of these columns. No matter how they're formatted here, it's only going to recognize them as strings. And it's very difficult to do any sort of mapping with strings. Even though they might be represented or appear to be a number, if they're formatted as a string, we won't be able to do the sort of mapping that we do. So anyways, I'll get around to that and I'll show this to you. This is probably another reason why we want to pare down the file that we are importing, because basically what the file is, the separate file, identifies which of these columns here are strings, actually, which of them are going to be integer or numbers, right? And so we're going to have one string and 1, 2, 3, 4, 5, 6, 7, 8 integers. All right, that aside, and of course we're going to be revisiting this when we have to get that file going, we need to save this as a comma delimited file. A comma delimited or a text file is only going to be able to save one sheet. It doesn't preserve the functionality of this workbook in any way whatsoever. We want to have active the page in our book that is going to be saved as that comma delimited file. That's this one right here. And I want to select File, Save As, and then I want to save this. We'll call this join test. I'm going to put in the extension CSV for comma separated value file. Okay, join test .csv. I believe that's going to be working for us later on. All right, so we get that. Click on Save. We get this warning here that it is going to be saving in a format that doesn't preserve the functionality of Excel. Save the active sheet. We have the active sheet. That is great. We do that. And then there are some features that won't be functional, right? And we want to go ahead and continue with that because what we want is the CSV file. We see jointest.csv up there. That's working well. And what I'm going to do is, at least right now, close this. I don't want to save this. It's already been saved, so I'm going to go ahead and select Don't Save. Now what I want to do is go to where I saved that file. And what I have here, you'll notice jointest.csv, and then there's a file here called jointest.csvt. This is the file that we need to create, and I've already done this ahead of time so we don't spend too much time just dealing with this. But if I open this file, one of the things that you're going to notice is that the only thing that is in this file is, in quotes, string or integer, okay, and they're separated by a comma, no space in between any of this, and the string, integer, and so on maps up with the fields that exist in the CSV file that we're importing, right? So this would be parcel ID, sector, activity, function, and so on. Okay, so we need to create this file, and I've done so ahead of time, but you need to create this file, and these data types need to match up with the variables that you are importing. I'll be happy to meet up with you, discuss this with you if and when you come to it. So anyways, it needs to be in the same folder, the same location as the file that you're going to be joining, right? So this matches up with that. Okay, they're paired, they're in the same folder, they're in the same location. It just needs to exist in the same location in the same way that when we opened up this shape file, we didn't need to specify all of these other files in here in order for that shape file to work. So the relationship between jointest.csv and jointest.csvt is exactly the same as this export output to shapefile and all of the other export output to files there. And if I didn't mention this already, we just need to be sure that the root name of this file or these two files are exactly the same. The only thing that's different is the fact that it's a CSVT file and a CSV file. Right? They need to be otherwise named exactly the same. Okay, so what we need to do in this instance, there's a couple of ways of bringing the data in. I think I had this problem once before in terms of opening up, finding. Here we'll make a mistake here. I'm almost positive, but what I just opened here is add delimited text layer, right? So that's exactly what we want to do. We want to add that layer to this. So I'm going to browse to jointest.csv, and if things should be working the way that they should, the join should take place. This has been really hinky for me. It has never really worked, not just on my computer here, but elsewhere. We want to check the comma separated value file. I also want to check this no geometry file. No geometry attribute. And what should pop up in this window right here is basically the spreadsheet that we're dealing with. And it's saying here no data is found in file. It's just been really problematic. And there's no way we can hit OK to make it happen. It's grayed out. So I'm going to cancel. The workaround that I found for this is just to open up the Finder window or the file window in Windows and go to the directory where everything exists. I've got jointest.csv. Just taking that, I'm going to drag it over into the layer panel. And you'll notice then it just pops up right here. I am not taking the jointest.csvt in with it. It is just there, and I'm keeping my fingers crossed and hoping that everything works out. Okay, so if I right-click and on join test, the file that I just brought in, click on Open Attribute Table, what I see is everything the way it should be. One of the sort of alarms is if the data in these cells were left aligned as opposed to right aligned. Left aligned usually signifies a string. Right aligned usually signifies a number of one sort, and so it's looking okay. So I'm kind of feeling hopeful about that. So just because these two files right here, these two layers, are in the same window doesn't necessarily mean at all that they are functionally related to each other. And what we need to do is to create that functionality or join the data. So what I'm going to do, I'm going to right-click on Export Output to. I am going to open the attribute table just to review this again and see everything, right? And you'll notice that I see parcel ID right here. Parcel ID, that is the key. We're going to be matching on that variable right there. So to begin the join process, I right-click on Export Output. Instead of going to the attribute table, I want to go to the Properties item down here. I click on that. There's a properties window that pops up here, and one of the selections is to join on this left side panel right here. If there are other layers that were joined to export output, they would show up within this window right here. That's not the case. These buttons right here allow us to add or select or edit the sort of relationship that we have with different files that we are adding. So we're going to be adding join test here. So I'm going to click on this plus button. And the join layer, I want to be join test. The join field, this is going to be the field in join test that I want to match with a field in export output to, right? It's going to be parcel ID. In fact, the only fields that we see in here are the fields that existed in that join test.csv. Target field, this is going to be the field name or the data that exists in the shape file that we're going to be adding to. So I see parcel ID. So we're going to be matching parcel ID to parcel ID. Once we have that done, I'm going to click on OK. And we see here that the join has been made. We don't necessarily know yet if the join is robust, so what I want to do is I want to close this out, and I want to open up the attribute table for export output to. And if I see that the data have been joined, right, that the information that is in join test is included in the information in the export output to shapefile, then everything's going okay. So I right click on that, go to open attribute table, and what I see here is all the fields that I expected to see in export output to, and what should pop up at the end is all the information that we collected and created. And that's what we see here. And in fact, you'll see that there's a prefix to each of the fields: join test sector, join test activity, join test function, and so on. Right? These are the 1 through 9s. the 0 and 1s, right, for this field, and then here these are the values, right, the dollars per square foot. All right, so things seem to be going okay. It's making me feel really comfortable. Excellent. So we're going to do a separate video for creating maps, but prior to doing that, I want to just show and test really quickly to find out if the join is actually a functional join. And I want to sort of create a little bit of a thematic display here. So what I do to do that, right? And basically, so color code, find out where all of the different sort of activity, types of activity or types of function or types of ownership and things of that nature exist throughout our study area. The way that we do that, we want to right-click on the layer that we actually do want to create that sort of thematic display, and then what we do is go to Properties. Right, same place that we went to Join. Okay, so see, we left off at Join and it comes up at Join, but what we're going to do is go to what we see as Style. Right. Now, the thing that we need to understand when we're creating anything thematic is that there are different types of data that are more appropriate for different types of display. We see something here, single symbol. That's basically what we're seeing right here. A single symbol that is fuchsia, and everything that is an actual object is colored fuchsia. And that's just uh, not very exciting in that sense. We have categorized as another option. This is for what I guess we would call discrete numbers or nominal information. And what categorized means is that we have very few discrete or different numbers. Categorized is a good way of mapping the LBCS dimensions, right? There's only 9 categories for each of the dimensions. And so it wouldn't be too cluttered if we just assigned a single color per category. And then with something like the value, graduated is something that would be more useful for that. That's for the sort of information or the sort of data that is continuous in nature, that we have a very, very large number of unique values, and it makes sense that it would be graduated in the sense of what we call a color ramp. If we use the color blue, it would be a ramp of colors from very light blue to very dark blue. And this will make sense in a little bit. So anyways, if we want to get a categorized sort of a theme, we click on categorized, and what we want to do here in column is identify which column we wish to map. And so this would be one of those LBCS dimensions, or it would be the sector or block data, or it would be the local owner, absentee owner data. Let's go and sort of map. Let's do activity. So we got join test, activity. Click on that. And let's just go ahead and keep it on random colors there. But once we select this, what should pop up in this window are all of the different categories and the colors associated with that, which basically ends up becoming a legend. In order to make that happen, what I need to do is click on Classify. It classifies the data in the shape file and assigns the appropriate colors to the appropriate LBCS dimension category. So I click on Classify, and I have values 1 through 9, and I have a legend here, and I'm able to edit these if I wanted to. So whatever code 1 is for activity, I think that's residential, right? I could type in residential in the legend right here. But that wouldn't be showing up really until we actually created a map. Right, so we've got this. I'm going to go ahead and click OK. And what we have here now is all of the different, all 9 of the single-digit LBCS activity dimensions. All right, pretty colorful map there. All right, and then now what I'd like to do is to try it in a slightly different manner. Right, if I want to go back to that window, right-click, Properties, and here I am with the layer properties. I'm going to create a graduated map. Right, the most appropriate data item here for this would be the tax value. Again, this is a value, dollars per square foot of the total assessed total assessed dollar value of the property itself. And then I've got got this symbol. I'm not going to change that. What I want to do here is a couple of things. Um, Going down to this area right here, the mode, I think we went through this before. There are a number of different ways of sort of separating all 130 of the separate values that we have here. What equal interval does is it takes the lowest value and the highest value, and then it creates equally wide categories. So here we got 5 classes. So in between the lowest value and the highest value, we create 5 categories of equal width. Right? What quantile does is that it takes 130 observations or parcels that we have here, and it rank orders them, and it divides all 130 into 5 equally populated categories, as opposed to what equal interval was, which is 5 intervals that were equally spaced, right? Or that had a magnitude of difference between each category's low and high value. Okay, so what I'm going to do is I like quantiles, right? They're kind of easy to talk about, so I'm going to go ahead and do that. Right, I click on classify. One of the things you'll notice is that this color ramp specifies, what sort of graduation between low value and high value we want, so we have the lowest values with the lightest color, and then the highest values with the darkest colors. Right, so if I click OK, once I've done that, we change colors. And so what we have here, each color is represented by an equal number of parcels. Okay, and then whatever the value distribution breakdown is or sorting follows an equally populated category. So this is one way of describing it. And just to show you the difference between how something is displayed in quantiles, here we have 5 equally populated categories, and the width of the category varies, right, depending upon the distribution of income within each of these equally populated categories. Right, I'm going to go back to properties, and we'll have 5 categories, but have that be of equal interval. Right, click OK. And what we have is a tremendous amount of over-representation on the lower end. Okay, tremendous amount of representation on lower value properties. There's really only a couple of extremely dark categories. We've got this parcel right here and this parcel right here that are the most, I guess we would say, the most expensive properties based on per square foot value. Why that's the case, I don't know what property this is right now. In fact, well, maybe we can look at it. Do I have my inspector button? Oh, here it is. Which one is this, by the way? Wolfies. Oh my goodness. All right, so Wolfies is an extremely high value property. Damn small place, right? But extremely high valued property that is, I mean, in the same category as Appalachian State University and the high value property there. It's kind of an interesting thing to observe right here. Okay, good. So this is, oh my goodness, this is the end of the video. What we will do is take this information in the next video and learn how to create a layout or a map that we can then export and put into our reports.